Okay, guys, we are on 7.4. We are still going to today be using a squared plus b squared equals c squared. We're just going to be doing this on graphs. All right, so let's take a look at the beginning question. So Thomas and Jim are outside a haunted castle ride and want to get to the clown tent in time for the next show. Okay, so they are right here and they want to get to the clown tent. That's where they want to go. So if we're taking a look at this, how can you represent the starred locations on a coordinate grid? Now, don't forget we have the x-axis, comma, the y-axis goes up and down, and we know that points are x, comma, y. So when you have a coordinate, so let's look at this castle right here. I said that was 1, comma, 3, because if this is the x-axis right here, I'll try to highlight it in black so you can see. I'll do my best. There we go. That's my x-axis. And this would be my y-axis, up and down. So this point, remember points are x, comma, y. So this point right here lines up with 1 on the x-axis, comma, 3 on the y-axis. And this other star over here, this would line up with 1, 2, 3, 4, comma, and it lines up on the y-axis at 1, so 4, comma, 1. So let's put them over here on this graph. We've got 1, comma, 3, 1, 2, 3, and 4, comma, 1. And GPS uses coordinates very similar to this. They use latitude and longitude. But 4, comma, 1 is right here. And Jim says that the marked yellow paths show the shortest path to the tent. So let's just look at that. What he means, and I'll put this in my yellow right here. He's saying that the shortest distance from this start point to this point would be going across and then down. You might have heard the phrase, the shortest distance between any 2 points is a straight line. So what they're saying is, I know that the shortest distance between this star and this star wouldn't be by following the gold path right here. It would actually be by cutting through these grids and getting from there to there. Notice we just drew a right triangle. So if I'm looking right here at my right triangle, and I'll put this in yellow so you can follow what we're doing. This is the path that they say to take. However, I know the shortest distance is from here to here. Now, the thing that you're going to notice, and I'll use yellow here, you're going to notice that it's really easy to count the boxes when your lines are perfectly horizontal, that means across, or perfectly up and down. It's just a matter of saying this one is 3 blocks long, and this side right here is 2 blocks long. Where it gets difficult is when you try to figure out the length of a diagonal line on a graph. It's hard to tell if the line is cutting exactly through halfway through the box. See right here, it's cutting through, I have no idea, that might be a third, it might be a quarter, it might be a fifth, I don't know. And it's hard to tell the exact distance of a diagonal line on a graph. But we know how to use the Pythagorean Theorem. We have a right triangle. We know 2 sides of the right triangle. We're missing one side. We know we could use a squared plus b squared equals c squared. And see these yellow lines, they would be my legs. The green line is my hypotenuse. And don't forget, in a Pythagorean theorem, side C is always your longest side. And it's across from the right angle. So right here, I'm going to label this side C. And then we're just going to use what we already knew how to do. We would use a squared plus b squared equals c squared. And we're going to plug our numbers in. Again, you have 2 points. If you connect them on a graph and it makes a diagonal line, it's hard to tell the exact distance. But if you're able to draw in a right triangle, you can use a squared plus b squared equals c squared. So it really doesn't matter. A and b are interchangeable. They're the legs. I'll just make a2 and b3. As long as you get c in the right spot, you're all set. And then we're solving an equation. So I draw my line through the equal sign. 2 squared is 4. 3 squared means 3 times 3 is 9 equals c squared. 4 plus 9 is 13 equals c squared. And when we're solving an equation, we need to undo squaring. And the way you undo squaring is by square root because they're opposites. They cancel out. And I need the square root of 13, which is 3.6055. So I will round that to find the distance. It doesn't really say, so I'm going to use my judgment and I'm going to write 3.6. And I don't really know what the units are. I don't think it said what it was. Oh, 1 grid square equals 1 centimeter by 1 centimeter. That's okay. And each centimeter is 500 feet. So I know that this would be 3.6 units. And I know those units, each one would be 3.6 centimeters. And I know that each centimeter is, let me go back up here one more time, 500 feet. So each one of those centimeters is 500 feet. So what I want to do is I want to multiply that by 500. So 3.6, 3 6/10 times 500 gives me 1,800, and I believe that was feet. So that is my distance right there. That's my diagonal distance. So I will put side C is 1,800 feet. Now let's go back and let's look at the distance for these other ones. This one was 3 units long. So the side that was 3 units long, each unit is a centimeter and each centimeter is 500 square feet. So I'm going to do 3 times 500. And that is 1,500 feet. And this side was 2 blocks, and each block is a centimeter, and each centimeter is 500 square feet. So 2 times 500 is 1,000 feet. And so if you're following that yellow path, you're going 1,500 feet to the east and 1,000 feet south. You add those together, and that's a total of 2,500 feet that you're walking. And so the shortest distance if you cut through those little sections, that would only cause you to walk 1,800 feet. But the main point is when you have a diagonal on a graph, it's hard to tell the distance, draw on a right triangle, use a squared plus b squared equals c squared. So let's try this right here. Let's try it. What is the distance between points A and B? Now, I don't see anything telling me that this is a real map or anything, so we are just straight up looking at the graph. So I want the distance between A and B. So I draw my line. It cuts through the graph. I can't tell exactly what that is. I could have an idea, but I wouldn't know exactly. So what I'm going to do is I'm going to draw in a right triangle. That way I have vertical and horizontal lines that are very easy to count. So this one is 2. This side is 2 long. And we're missing the third side. So here's my right angle. It points to side C. So I know that I need to use a squared plus b squared equals c squared because I'm missing one side of a right triangle. A and b are the legs. Notice they make an L. So I'm just going to plug my numbers in. 2 squared plus 2 squared equals c squared. I know this is really 4 plus 4, which is 8, equals c squared. And I'm trying to find out what side C is, so I have to undo squaring by square root. Whatever you do to one side, do to the other. So in my calculator, second x squared 8, or if you're going into decimals, just square root of 8 is 2.828427125. That's an irrational number because it goes on forever and it's jumbled up and it can't ever be changed to a fraction. So I am going to, it doesn't say, it just says about, so I'm going to use my judgment and make it 2.8 units. And there is no scale, there is no map, so I just put 2.8. And now we're going to double check this very simply. I know the hypotenuse should be the longest side, and 2.8 is longer than each of the legs. So that's it. If we take a look at number 2, sometimes they'll step this up one notch. You don't have to do all the work that they did. I would not do that personally. Sometimes they'll have you find the lengths of the sides and then they want the perimeter. So that's just an extra step. When you find the perimeter, you add the sides together. So let's look at this diagram right here. We have our triangle. It's really easy. If I need the perimeter, it's really easy to see that this side is 3. This side is 5. See how I didn't have to do they did a lot of work for that. Just count the boxes. And the diagonal line, it's hard to tell the exact distance of the diagonal line on this triangle. But I know I've got a right triangle. I've got 2 sides. I'm missing a side. I can use a squared plus b squared equals c squared. So follow what I'm doing in blue and maybe write this down off to the side rather than looking at everything they did. So just a squared plus b squared equals c squared. Remember, side C is the hypotenuse. It's across from the right angle, so I'll label that with a C. I will put these numbers in for A and B. And we are trying to find C. This is an equation, so I draw my line through the equation. 3 squared is 9. 5 squared is 25. When I add 9 plus 25, I get 34 equals C squared. And then I want to undo squaring by square root. Squaring and square root cancel out, so I'm left with C equals, I get out my calculator, and I do second x squared 34, or square root of 34. I get 5.83. It doesn't really say what to round it to, so I'm going to use my judgment and round it to the nearest tenth. 5.8. I'm going to go back up here and put in 5.8. Now, don't forget the question is find the perimeter. So we need to add the sides. For a perimeter, think of putting in a fence. When you put a fence around your yard, that is the perimeter. Or think of a security guard patrolling the perimeter of a property, okay? You just see how far they walk, you just add up the sides. So I'm going to add 5.8 plus 5 plus 3. And so I end up with, now here's where you kind of use the associative property here. 5 plus 5 is 10, 11, 12, 13.8. So you can group these together so you could do the math in your head if you need to. And this is 13.8, and I don't see any like feet, inches, centimeters, so I'm just going to write units or blocks. Either one is fine. And that's my perimeter. Sorry, I'm writing really messy with my mouse here. Okay, so 13.8. So let's just try this one, and then that's pretty much it. 2 comma 5, don't forget points are x comma y. So you might need graph paper for this. Actually, you will need graph paper. 2 comma 5, so 2 comma 5 is right here. So this point lines up with 2 on the x-axis, and it lines up with 5 on the y. 5 comma negative 1 is right here because it lines up with 5 on the x, and it lines up with negative 1 on the y. And 2 comma negative 1 is right here because this point lines up with 2 on the x-axis, and it lines up with negative 1 on the y. So now it says I want the perimeter of this triangle, so I'm going to draw in my triangle the best I can. All right, the vertical up and down and horizontal across sides are really easy. 1, 2, 3, 4, 5, 6. This side is 1, 2, 3 long. And we're trying to find side C. And another good thing to check too, just to make sure you counted right, see how this is negative 1 up to 5, so that's a height of 6. This right here goes from 2 to 5, so that's a distance of 3. So now I need the perimeter, and I just need the length of this diagonal side, and I really can't count the boxes and understand exactly what it is, but I do have a right triangle, so I'm going to do a squared plus b squared, and I'm cheating a little, I'm not writing the formula. Hopefully you're following okay. Equals c squared. Draw my line through the equal sign. I get 36 plus 9, which is 45, equals c squared. And to get c alone, we undo squaring by square root because they cancel out, they're opposites. And in my calculator, I'm going to do the square root of 45, and I get 6.7. I'll round it to the nearest tenth because that was an irrational number that popped up. I'm going to also put 6.7 right here on my diagram. And now when I need to find the perimeter, I just have to add the sides. That's it. So I've got 6, I've got 6.7, and I've got 3. So 6 and 6 is 12, 13, 14, 15.7. And I don't see any like real units, so I'm just going to label it with units or boxes, blocks. And that's it. If we go to the next one, I am going to skip this example. Number 3 is not necessary. The only thing I want you to keep in mind is once in a while they'll throw in a question, and I always see kids do way too much work. Just look at step 1 right here. Sometimes they'll give you tough questions, then they give you a really easy question, and kids get it wrong. What's the distance between these 2 points? This isn't a diagonal line. It's horizontal. It's straight across. The distance is 4. So if something's really easy, just count. If you need the distance of a diagonal line on a graph, though, that's when you're drawing your right triangle in and doing a squared plus b squared equals c squared.